Okay, hello everyone. Let me ask one thing. Is my voice audible to you? Uh, Bhagiraj, can you tell me whether my voice is audible to you or not?
Yes, yes,
You can
yes,
write
ma'am.
in
Yeah,
the
it's
chat
audible.
box if you are unable to speak. Means if you are unable to unmute yourself.
Yeah, yes, ma'am. I can hear you.
Hello? Bhagiraj, is my voice audible to you?
Yes, yes, yes.
Okay, thank you so much. So, let me introduce myself first. So I'm Gitanjali Jaina. I'm a research scholar from IIT Delhi, and I'm the TA, NPTEL TA for this course. Sorry, PMRF TA for this course. So in each session, my main motive is to go through the lecture content and uh, solve some problems in front of you so that it will help you to clarify the concept as well as in between if you have any doubts about the assignment that has been floated in the NPTEL side, you can ask me, but please ask me after the solution, after release of the solution. Before that I cannot able to solve the problems that is related to assignment. Okay, so we'll solve the assignment problem after when the solution got released, and besides I will also solve some additional problem that will be helpful for you to clarify the concept as well as for your numerical understanding. Okay, so please feel free to ask me any doubt at any time. So it's like a interactive session. So you are allowed to ask me any doubts regarding the assignment or regarding the lecture as well as regarding the tutorial that I am going to do now. Okay, so let us get started. So if you recall in the first week content, it's all based on what is the Maxwell's equation and how the Maxwell's equation behave inside a dielectric medium as well as how the Maxwell's equation behave inside in a free space. And first, what we have seen how what is the condition for a wave to satisfy for a expression to satisfy a wave equation. So the first question is based on that concept only. So it's let me read out the question for you. So the question is, which one of the following doesn't represent a wave? So there are four options. First is it's a sinusoidal term, and second is it's the product of a sinusoidal with a exponential term, e to power minus x square by sigma square, and C and D. So let us see what are the equation for a wave. So if you recall, so let me write in another call, I think. So wave equation, it's nothing like, so if you have a medium, it's like dou square psi by, let's say it's one dimensional. So dou x square, it is 1 by v square, dou square psi by dou t square. So this is the condition for the wave equation. And you already know, I think you already know this equation. So we just have to see whether this waveform, let us say we are taking the first one, whether it satisfies the wave equation or not. And if you recall, it's a expression of a plane wave, so it should satisfy the wave equation. So I think the derivative you can easily calculate it. So dou square psi by dou x square, it will come out as a minus k square psi of xt. And what is the next part? So it's to calculate what is the dou square psi by dou t square. So whatever I'm writing on the white sheet, is it readable or do I have to write in big letter?
It's readable, ma'am.
Okay. So dou square psi by, okay, thank you. So dou square psi by dou t square, if you calculate it, it's like minus omega square psi of x t. And if you see, what will be 1 by v square dou square psi by dou t square minus omega square by v square psi of xt. And if you recall, the inside a medium, v, you can write it as a v is omega by k. So this you already know. So that means this is minus k square psi of xt. So this indicate that for this wave equation we have dou square psi by dou x square is 1 by v square dou square psi by dou t square. So this means this is a this wave. This can represent a wave. So A part is a wave. So if you take the B part, so if psi of xt, it is a e to power minus x square by sigma square cos omega t. So now if you take the derivative dou psi by dou x, it's nothing but, I think you can calculate, it's 2x y sigma square psi of xt, right? And if you take another derivative, so it's minus 2 sigma square psi of xt minus 2x by sigma square dou psi by dou x, right? And dou psi by dou x, you already know this is this term. So that means this will come out as sigma square psi of x t, right? So now if you factor out the common terms, so it will be sigma square, there is minus 1 plus x square psi of x t. So this is the LHS side. Now if you calculate what is dou psi by dou t, so this involves a cos term. So that means you will get uh, minus omega square psi of xt, right? And you can see these two are not equivalent. So this is dou square psi by dou t square. So this indicate dou square by dou x square is not equal to 1 by v square dou square psi by dou t square. So it doesn't represent a wave, B part. So that means this is not a wave equation. Now if you see the third part, so instead of cos we have e to power minus t square by tau square. So let us see whether this satisfy the wave equation. So we have psi of xt e to power minus x square by sigma square and e to power minus t square by tau square. So if you calculate dou square by dou x square, so this will be equal to what we have done before because the terms are equal. So that means this will come out as 2 by sigma square minus 1 plus 2x square by sigma square psi of xt. And for the t part, so we'll get the same form, but instead of sigma, we have tau. So it will come out as 2 by tau square minus 1 plus 2 t square tau square psi of xt. And you can see these two are not equal. So if you take 1 by v square of this, these are not equal. So that means this, if you take a wave function of the form or electric field, which is expression like x square by sigma square and e to power minus t square by sigma square, then it is not a wave. Doesn't represent a wave. So for the C is not a wave. So if you see the D part, it has a square term, but it's like x minus vt square. So instead of the separate term like here, we have the combined term. Now if you calculate it, x minus vt square, it was there, it is sigma, I think, is sigma square. Now if you take the derivative with respect to x, so this is nothing but minus 2 x minus vt sigma square psi of xt. And if you take the next derivative, double derivative, so it will be like minus 2 psi of xt by sigma square plus minus 2 x minus vt by sigma square whole square psi of xt. So this is the LHS side. So now if you take the RHS part, that is dou psi by dou t square. So let us see what is the first order derivative, which is dou psi by dou t. So this will come out as 2v x minus vt by sigma square psi of xt. And if you take the double derivative then, so it will be like 2 minus 2v square by sigma square psi of xt plus 2v x minus vt sigma square whole square psi of xt. Okay, so if you take 1 by v square of dou square psi by dou t square, so this v square will cancel out. So what you will get is minus 2 psi of xt by sigma square plus 2 x minus vt sigma square whole square psi of xt. Okay. So now if you compare this term with this term, these are equivalent. So this shows that this psi that we have now It's a wave. Okay. So in this question, we have two forms which satisfies a wave equation, which is A and D. A is it's a plane wave expression, and psi of xt it's x minus vt square by sigma square. This satisfies the wave equation, but C and D they do not satisfy the wave equation. Okay, this one is easy. I think if you recall the what is the wave equation, then you can easily follow up the answer. Okay, so let us move to the next question. Please go through the question once. So the question is for an expolarized plane electromagnetic wave propagating in the z direction, we have the electric field S, which is given by this expression. Okay, now it is asking you to find out what is the magnetic field that is associated with this plane electromagnetic wave. So if you recall, what is the relation between E and B? So B is given by K cross E by omega, right? E is already given to you. Now your main work is to find out what is K here. So if you compare this expression with the general form, which is EJ is EOJ exponential I toward K dot R minus omega t. So this is the general form. So if you compare it, it's like we have only the Z, the propagation vector, which is K, is in the Z direction, that is Kz, it is equal to K. Okay, so that means the K vector here is K Z, Zk, right? So now you know the all the form that you need. So you can easily calculate what is B here. So B is nothing but so it's A cross E by omega. So K is K Z cap cross X cap E0 exponential I toward Kz minus omega t divided by omega. And the cross product of X with, sorry, Z with X will give Y cap, right? So it is Y cap E by omega E0 exponential I toward Kz minus omega t. This you can take it as a some magnitude, some amplitude B0. So the expression for B is B0 Y cap exponential I toward Kz minus omega t. So if you know what is the relation between E and B, then you can easily calculate what is the expression for B if E is given, or expression for E for expression for B if E is given. So we'll move to the next part. So third question, it's it's based on whether the electric field that is given to you, it's electrostatic field or it's not electrostatic field. So let me read out the question. So the question is like, which one of the following is an impossible electrostatic field? So if you recall, what are the condition for the electrostatic field? So for a field to be electrostatic, we have call of E, it should be equal to 0. And another is the path integral around the whole path, it is also 0. But that is not required in here. So let us see which one is following this condition for a field to be electrostatic. So you have in first E is A y square x cap plus 2xy z square y cap plus 2yz z cap. Okay. So, and what is the form for call of E? So in Cartesian coordinate, you have call of E as I cap, j cap, and k cap. And you know the form for this del operator, it is dou by dou x, dou by dou y, and dou by dou z. And E, you have to separate the components, right? So this is Ex. So Ex is y square. Then Ey, which is 2xy plus z square. And the third is 2yz. So this you have to solve it. So if you see y I cap, it is nothing but dou by dou y of 2yz minus dou by dou z of 2xy plus z square. This is the I cap term. For j, it is minus j dou by dou x of 2yz minus dou by dou z of y square plus k cap. I think this you already know if you recall the electrodynamics codes. So this is dou by dou x of 2xy plus z square minus dou by dou y of y square. So if you see the first term, sorry, this one, this will give minus 2z, right? Sorry, plus 2z. This will give 2z. And this also give 2z minus j cap. So here dou by dou x 2yz. So this is 0. Right? There is no x term here. This one is also 0 because dou by dou z of y square. And so that means this is 0 plus k cap. And this term, the term here you will give 2y minus, and this will also give 2y. So that means this call of E is 0 here. So it satisfies the condition for the field, for a field to be electrostatic. That means this field that is given here, it's a electrostatic field. Now if you see, the obvious answer will be answer B. But let us check whether it is actually the answer, whether it actually follows the condition or not. So for B part, we have this expression. So E is A xy x cap plus 2yz y cap plus 2x, sorry, I think 3xz z cap. Hmm. So for this, we have to follow the same procedure. That is whether call of E, it is 0 or not. So this is I cap, j cap, k cap. This is dou by dou x, dou by dou y, dou by dou z. And Ax is xy here, Ey is 2yz here, and Ez is 3xz here. Now if you take the cross term, it is dou by dou y of 3xz minus dou by dou z of 2yz minus j cap dou by dou x of 3xz minus dou by dou z of xy, and there is a term k cap is dou by dou x of 2yz minus dou by dou y of xy. So if you see this term is 0. And this will give minus 2z, right? So I cap minus 2z. And this will give 3z. This one is 0. This one is also 0. And this will give x. So the answer you will get is minus 3z j cap minus x j cap. So that means for this field, this curl, it is non-zero. So it's not an electrostatic field because it is not satisfying the condition for a field to be electrostatic. Okay, I think this is clear to you. You just have to remember this condition. So we'll move to the next question. Please go through the question once. So the question is an electromagnetic wave. It is described by its electric field E. The wave has a amplitude E0 and angular frequency omega and wavelength lambda. Travels at a speed c. outward in the direction of the unit propagation vector, which is kk is 4ik plus 2jk divided by root 20. So now it is asking write an expression for the scalar value of the electric field. So what is the general equation for the electric field? Ej is the amplitude part and the phase part. So k dot r, kj dot r. This you can write it as k0. Instead of k0, you can write it k dot rk, which is x ik plus yjk plus zkk. So kk is already given to you. It is by this expression. Okay. So k you already know. K, if you recall, it is nothing but 2 pi by lambda. Right? So this is 2 pi over lambda. K cap is 4 I cap plus, don't confuse this one with this vector. So this is the k cap here, it is a propagation vector, and the k cap here is a unit vector along direction. Okay. So it is 4 I cap plus 2 j cap root 20 I cap plus y j cap. And if you solve it, you will get 2 pi root over 20 lambda 4x plus 2y. So now the expression will be easy. So is a is, it's already given, the amplitude is E, right? E0. So E0 exponential I k dot r, which is 2 pi over lambda root over 20 lambda 4x plus 2y minus omega t. Okay, so this is the final form. And scalar, it is nothing but if you scale just omitting the vector coordinate, vector form. So it is E0 exponential I 2 pi root 20 lambda 4x plus 2y minus omega t. So is this clear to you?
Yes, yes.
Okay. So let me move to the next question then. So the question says, a plane electromagnetic wave, it is propagating in a dielectric medium, and the electric field is, it is given by E x y z t is E0 x cap minus z cap by root 3 exponential ik0 minus ct plus x plus root 3z So this is the complete expression for the electric field. Now it is asking you, so E0, it's the information that is C is the speed of light in vacuum, E0 is the amplitude, K0 are the constant. S, K, Y, K are the unit vector along X and Z direction. Now it is asking you to find out what is the refractive index and dielectric constant of the medium. Okay, so if you find out what is the refractive index, then you can easily calculate what is the dielectric constant. And for refractive index, what you need? So refractive index N, you know it is C by V, right? And V here it is nothing but omega by K. So your work is to find out what is omega here and what is K here. So if you see this expression and compare it to the general form, that is EJ is EOJ, e to power I AZ R minus omega t. So this is the general form. So that means the omega here, and if you compare this to this, so omega is the coefficient of t. So here, if you see this expression, beside t there is minus of, sorry, K0C. So that means omega here it is, I think this color is not visible. So omega here it is nothing but K0C, right? And for K term, so you have to look for what is the coefficient of the coordinates, which is here. There is a K0 here. So that means if you see Kx will be K0 and Ky is root 3 K0. So what will be K then? Magnitude of K, it will be square root Kx square plus Ky square. So this will come out as 2K0. Now the first thing is to find out what is V here. So V is omega divided by K. Omega is K0C and K vector it is 2 times K0. So that means this is C by 2, right? So now N will be C by V, which is 2. So the refractive index of the medium is, it is 2. And the refractive index, you can express it as a square root of epsilon R if the medium is non-magnetic. This is 2. So that means epsilon R will be 4. Okay. So this is the answers. So during calculation, when I'm doing this solution, if you have any doubts, then you can feel free to stop me anytime so that you can clarify your doubt at that exact moment. Okay. Next question is, it's also kind of same to I think the question number 2. So it is given the electric field of a electromagnetic wave. It is given by E as E0 cos pi 0.3x 0.4y minus 1000 t. It is in the k cap direction. Okay, so now it is asking you to find out what is the magnetic field. So B you already know, it is A cross E divided by omega. So the first thing is to find out what is the expression for K by looking at this form. Okay. So if you see the coefficient of T, it will be omega, right? So omega here it is nothing but 1000 pi. Okay. And the coefficient of X, it is 0.3. That means Kx is 0.3 pi. And coefficient of Y is 0.4 pi. So that means Ky, it is 0.4 pi. So the K vector now we have is Kx I cap plus Ky j cap, which is 0.3 pi I cap plus 0.4 pi j cap. And E is already given. So that means B is 0.3 pi I cap plus 0.4 pi j cap divided by omega, which is 1000 pi. And there is a cross term which is E is k cap E0 cos pi 0.3x plus 0.4y minus 1000 t. The pi will cancel here. So, and 0.3, what is the cross product? So if you take the cross product of I cap with k cap, it is minus j cap, right? It is minus j cap plus j cap with k cap, it is I cap, is 0.4 I cap and E0, there is 1000 here, cos pi 0.3x plus 0.4y minus 1000 t. Okay, so the final will be 10 to the minus 3 4 I cap minus 3 j cap E0 cos pi 0.3x plus 0.4y minus 1000 t. So this is the answer. So answer will be so this is point, I think 10 to the minus 4 because it is 10 to the 3 and there is point here. So answer will be B. Okay. Now let us move to the next question. Please go through the question once. So the question says, and linearly polarized electromagnetic wave with its z-oriented magnetic field of amplitude b equal to v0 is propagating in the xy plane. The wave is incident on a dielectric interface at y equal to 0 at an angle of incidence theta is 60 degrees. The refractive index of the dielectric is 1.8. So the first part, it is to find out what is the expression of magnetic field for the incident, reflected and transmitted wave. Okay, so whenever this kind of question is given, it's better to draw the ray diagram, how the ray is propagating in the plane of incidence. So if you once you draw this ray diagram, then it will be easier for you to write the expression of incident, reflected and transmitted wave. Okay, so it is given the wave is propagating in the xy plane, right? So it is propagating along the xy plane. So let us take it is this direction is x and this direction is y. And this part, this is the point y equal to 0. And the angle of incidence it is given is, let us say, so this is the angle of incidence theta I, which is 60 degree. And N1 it is already given 1.8. So now when this ray, one minute. So it will be get refracted, right? So this is, let us say this is the incident wave. This get reflected here and this get transmitted here. So let us see what is the incident wave expression, incident field. For this, what you need, so you need Ki dot R, right? So Ki, what is the expression for Ki? So if you see, this is the Ki direction. So that means, sorry, this, I think I made a mistake. So the wave is incident on a dielectric interface. That means the wave was initially propagating in n equal to 1. Now it is entering the medium. N2 is 1.8. Okay. So now you can calculate what is the Ki. So Ki is nothing but, so in free space, that is, let us see the first medium, it is the free space, right? So it will be Ki, it is K0. The magnitude is K0. Now if you see the component of this K0, it is in the y direction, it is K0 cos theta I, right? I kept, and in the x direction, it is K0 sin theta I, JQ. I think this is clear to you. If not, let me know. Okay. So this is the Ki direction. You are taking the projection along y, it is cos theta I, and along x, it is sin theta I. So that means if you put K0, sorry, theta is 60 degree, it will be K0 sine 60. So this will K0 by 2 I cap plus root 3 K0 by 2 J. So, sorry, mistake. Cos theta is along y direction. That means this is j cap here and this is I cap here. This is j cap and this is I cap. So you know what is Ki. Now you can easily find out what is the expression for B. Incident, which is B0, and it is oriented along Z direction. It is Z oriented magnetic field. So that means it is K cap exponential I K dot R. It will be K0 by 2 Y plus root 3 by 2 K0 X minus omega t. Clear? So this will be the expression for the incident magnetic field. And for the reflected part, you know that the reflected angle will be theta r. It will be 60 only. And because it's a reflected wave, which is getting reflected at y equal to 0, that means only the y part, it will change the sign upon reflection. Okay, so initially the wave is like, let me draw here. So initially the k is like this, the propagation vector. Now it is like this. So the x part, which is the horizontal part, remains same. Only the y part will flip the sign. So that is why the kr reflected is root 3 k0 by 2 I cap minus k0 by 2 j cap. So it is similar to ki, but only the sign of the y part, it will change the sign. So B reflected will be let's say it is BOR K cap exponential I cap K0 y by 2 minus K0 y by 2 plus root 3 K0 by 2 x minus omega t. This is for the reflected wave. Now for the transmitted wave. So you know that whenever a wave travels from medium 1 to medium 2, the omega remains same, only the k vector, that is the propagation vector, it changes. So to calculate the propagation vector, so let us say this is ki, this is kt, and this is theta I, and this is theta t. So that means kt vector, it is nothing but kt magnitude. This is y direction, this is x direction. So this is kt cos theta t jk plus kt sin theta t ik. And in this expression, you don't know what is theta t here and what is kt here. So to find out this, you can use Snell's law. That is n1 sin theta 1, it is equal to n2 sin theta 2. N1 it is 1 here, N2 it is given 1.8. So that means is 1 into sine 60 is 1.8 into sine theta 2, which is theta t. So that means sine theta 2, it will be sine 60 by 1.8. And if you calculate it, so sine 60, it is root 3 by 2. So it will come 5 root 3 by 18. Okay. So you got sine theta t as 5 root 3 by 18. So you got what is theta t here. Now your main next work is to find out what is kt here. Kt in the medium. So for that, what you can do, you can again use the Snell's law. That is, if you recall, n is c by v, and v we know it is omega by k. And when wave travels from medium 1 to medium 2, omega remains same. If it is a same source, only the k changes. That means n is directly proportional to k. So you can write the Snell's law as k1 sine theta 1 is k2 sine theta 2. So that means ki sine theta I, it is kt sine theta t. And you already know what is ki. It is k0, right? And sine, it is sine 60. And sine theta t is 5 root 3 by 18 into kt. So this is root 3 by 2. And if you calculate it, kt will come out as root 3 will cancel. So 9 by 5 k0. Okay. So you know what is kt now. So the next is to find out what is the kt vector, which is kt cos theta t jk plus kt sin theta t ik. So kt is 9 by 5 k0 cos theta t. You can find out by taking root over of 1 minus sine square theta t. You know what is sine theta t? So cos theta t you can easily find out using this trigonometric relation. Okay. So cos theta t, it will come out as root over of 249 divided by 18 jk plus 9 by 5 k0 5 root 3 by 18 ik. So the B transmitted will be B0t z cap exponential I. So this will cancel to. So this is root over of 249 by 10 k0 y plus root 3 by 2 k0 x minus omega t. So this is the complete expression for the transmitted wave. Okay. So you find out what is the expression for incident, what is the expression for reflected, and what is the expression for transmitted wave. Now the next part is to calculate how does the velocity get affected inside the dielectric medium. So you know that whenever wave travels, the velocity got changed. And I think you already know the answer for this. So in medium 1, you have n equal to 1, right? So that means the velocity is c here. And in medium 2, so n is already given, so it's you can easily calculate what is V. V is C by N, which is C by 1.8. So it get slowed down whenever it enters the dielectric medium, which is refractive index 1.8. Okay. Now let us move to the next question. So the next is it's a conceptual one. It's based on the total internal reflection concept. So if you recall the lecture, whenever the wave travels from a denser medium to a rarer medium, then it get reflected back to the same medium whenever the angle of incidence is greater than critical angle. Okay. So the question is like, which one of the following is not true for total internal reflection? The first is TIR occurs at angle above critical angle, which is correct. And the second part is TIR. It is independent of the refractive index of the second medium. So, which is so TIR, it is independent of refractive index of the second medium, which is not true. It depends on what is the refractive index of first medium as well as what is the refractive index of the second medium. And C part, it is TIR leads to complete reflection of energy back to the first medium, which is not correct because whenever TIR occurs, there is a evanescent wave that penetrate to the second medium. Okay, that you have already seen in the I think in the lecture. So whenever there is a TIR, there is a evanescent wave here. So it is also not correct. And the large question is TIR occurs when wave travels from a medium of lower refractive index to a medium of higher refractive index, which is also not correct because it only occurs whenever wave travels from higher refractive index to a medium of lower refractive index. So that means these three options, these are not correct. So it's if you know the concept, then you can easily find out what is the answer to this question. So let us quickly move to the next question. It's also easy. So if you know how to find out the wave vector, the propagation vector, then you can easily find out the answer. So the question says, the displacement associated with a three-dimensional wave, it is psi of x, y, z, t. It is a cos root 3 by 2 kx plus half ky minus omega t. And it is telling so that the wave propagates along a direction making an angle 30 degree with the x-axis. Okay, so angle of incidence with respect to the x-axis is 30 degree. Now if you compare this to the usual form, that is the general expression of xyzt, it is a cos axx plus kyy minus omega t. So that means kx here it is root 3 by 2 k, and ky here it is half k. Now if you say, let us say it is making an angle theta, So it's easier to, let's say, is making an angle theta with the x-axis. So that means tan theta will be, it is ky by kx, right? So ky it is already given, it is half k, and this is root 3 by 2 k. This, it is 1 by root 3, which is tan theta is 1 by root 3. That means theta here it is 30 degree. Okay, so the wave it travels by making an angle 30 degree with the x-axis. Do you have any question till now? Otherwise, we'll move to the next question.
It's clear.
Okay, thank you. So let us see what the question 10 is. So it's telling obtain the unit vector along the direction y of propagation. Y is here, no, this is coming from, so there is no y here. Okay, obtain the unit vector along the direction of propagation for a wave. The displacement of it is given by psi of x, y, z, and t. It is a cos 2x plus 3y plus 4z minus 5t, where x, y, and z are the measured in centimeters and t in seconds. Then what will be the wavelength and frequency of the wave? So similarly, if you compare it, a cos kx plus kyy plus kzz minus omega t. So that means omega here it is 5 and kx it is 2, ky it is 3 and kz it is 4. So the question is asking what is the value of lambda here. So for lambda what you need? You need k, because k is 2 pi by lambda. So lambda is 2 pi over k, and 2 pi is kx square plus ky square plus kz square. And if you calculate it, it is 2 pi two square, 3 square plus 4 square. So it will come out as 2 pi by, it is 4, 9, 13, 16. So root over of 29. So which is 1.17 centimeter. And omega is 5 second units. That means frequency is 5 pi 2 pi, which will be 0. I think 796. And the question is what is the wavelength and frequency of the wave, as well as what is the unit vector along the direction of the propagation. So along the direction of propagation, we have k vector. So that means the unit vector will be kk. It is k by mod k. And k vector, it is kx ik plus ky jk plus kz kk whole divided by mod of k. That is root over of kx square plus ky square plus kz square. This you can easily calculate. It's already given kx, ky and kz is 2 by root over of 29 ik plus 3y root over of 29 jk plus 4 by root over of 29 kk. So this is the unit vector along the direction of the propagation. Please go through the question 11 once. Okay. So the question 11 says, it's also similar, I think, to the second question. So there is a plane polarized electromagnetic wave in free space at time t equal to 0. It is given by E is Ex Z E is tan jk exponential I 6x plus 8z minus tan ct. Then what is the magnetic field? So magnetic field B, it is K cross E by omega, and omega here is tan ct, right? Is tan ct. And to find out K, so we have to write Kx, it is Ik plus Ayjk plus Az kk. And if you see this expression, the wave is propagating in the x-z plane. So there is no ky term here. And kx is the coefficient of x. It is 6 ik plus, and kz is coefficient of z. It is 8 kk. Okay. So that means you know what is k now. So you just have to put the values to find out what is v. Is k cross e by omega. So this is 6 ik plus 8 cross tan jk exponential I 6x 8z minus tan ct divided by omega, which is tan ct. So if you take the cross product of I with j, you will get kk, right? So this is 60 kk plus kj, it is minus I, right? So you will get minus here, minus 80 ik. Exponential I 6x plus 8z minus tan z. So you already got the expression for B. It is 6 k cap minus 8 I cap over CT exponential I 6x plus 8z minus tan z. So this is the expression for magnetic field. You can see this numericals, these are quite easy. If you know what is the relation between B and E, and if you know how to calculate, how to find out what is the propagation vector if you are given an expression, then you can easily calculate what is B for this case. Okay. And these are crucial if you want to solve any higher problem, like a complicated problem. Now you have uh, the 12th question is, it is telling which one of the following uh, represents an electric field due to a time varying magnetic field. Question A, sorry, there are four options, and it is telling which one of the following represents an electric field due to a time varying magnetic field. So how you can approach this question? So for a electric field to represent a time varying magnetic field, that means the dou B by dou T term, it should be non-zero, right? If it is zero, then there is no time variation in magnetic field, then the electric field doesn't correspond to a time varying magnetic field. But if it is non-zero, then the electric field it will correspond to a time varying magnetic field. And you know that from the Maxwell's equation, dou B by dou T, so it is related to curl of E is minus dou B by dou T. And this is non-zero, means the curl should be non-zero so that it is corresponding to a time varying magnetic field. So the only work it is to find out what is for which expression this curl of E it is non-zero. So let us see case by case. For the E part, we have E. So these are all written in Cartesian coordinates. So there will be no change in expression for curl of E. So yk plus zk. So that means curl of E for this case is is I cap j cap, sorry, I cap j cap k cap here is x cap, y cap, and z cap. So this is dou by dou x, dou by dou y, dou by dou z. Ex is x here, ey is y here, and ez is z. So if you solve it, x cap will be dou by dou x of y minus dou x by dou y minus y cap dou by dou x of z minus dou by dou z of x plus z cap dou y by dou x minus dou x by dou y. And you can see here dou y by dou x it is 0. It is also 0. Dou z by dou x is 0. Dou x by dou z it is 0. Dou by dou x is 0 and dou x by dou y it is 0. That means for this field we have call of field, it is 0. That means it's a electrostatic field. So it doesn't represent to a time varying magnetic field. Now if you take B part, which is similar to this, but there is a minus Z term here. So E is K X plus Y cap minus Z cap. So if you take the call, it is X cap, Y cap, Z cap, dou by dou X, dou by dou Y, dou by dou Z. This is X, Y, and there is minus Z here. And this will be 0 only because it's similar to this, only this term here is minus Z. Okay. I think this will be easier, or if not, you can see for X cap, it is dou Y by dou Z by dou Y, which is 0, and dou Y by dou Z, which is 0. And for Y cap, it is dou dou Y, dou Z by dou X, which is 0, and dou X by dou Z, which is also 0. And similarly for Z cap, if you find out, it is also 0. That means it is also electrostatic field. So this is not the case, this is not the case. And second term, second option, it is B is X cap minus Y cap. And if you guess, it is also 0 because it is also similar to what we have in option A and C. Only there is no Z term here. And if you take the curl, it is X cap, Y cap, Z cap, dou by dou X, dou by dou Y, dou by dou Z. This is 0 here and this is X minus Y. And this will come out as 0 only. Okay. Now the option that is remaining is option D. So you can easily guess the answer. It is D only. But let us see whether it is the case or not. So for D part, we have K Y X cap minus X Y cap plus 2Z Z cap. Okay. Is K Y X cap minus X Y cap plus 2Z Z cap. So this is quite different from what we have in option A, B, C. So if you find out the call here, it is I cap, J cap. Sorry, I made a mistake also. It is not I cap, J cap, K cap. It is X cap, Y cap, and Z cap. So this is dou by dou X, dou by dou Y, dou by dou Z. And EX is Y here, EY is minus X here, and EZ is 2Z here. So this will be X cap, dou by dou Y of 2Z minus dou by dou Z of minus X minus Y cap, dou by dou X of 2Z minus dou by dou Z of Y. In the Z component, it is Z dou by dou X of minus X minus dou by dou Y for Y. You can easily see this term, it is 0. This is also 0. This is also 0. This is 0. But this term, it is -1. And this is 1. So that means curl of E, it is minus of 2zk, which is not equal to 0. So here the curl of E, it is non-zero. That means it's not a electrostatic field. So it represent a field due to a time varying magnetic field. So the answer will be option D here. Okay. So let us move to the next question then. So the question says, it's a linearly polarized electromagnetic wave. It is traveling in free space with the electric field E. It is given by this expression. And at time t equal to t0, it enters to a medium of refractive index 1.5. What is the electric field expression in the new medium and what is its speed? So initially it was traveling in free space. So that means the k vector, the velocity is v is equal to c, which is nothing but omega by k0. So that means if you find out from here, omega is ck0 or k0 is omega by c. And if you see this expression for the electric field, the kx, it is p here, right? The only propagation is along the direction of x. So that means k0 is kx and this omega by c, it is equal to kx, which is equal to p. Okay. Now, when it enters the medium, that is medium 2, which is refractive index 1.5. And we have already seen the velocity, it get decreased by a factor, which is refractive index of the medium. Okay, so this will be c by n and this will be c which is equal to n omega by k. So that means the k will be, I think my tab got disconnected. Okay. Please wait for 2 minutes. Okay. Is my screen visible? Okay. What happened? So please wait for 5 minutes. I am trying to connect my iPad. So joined this screen. Okay, I think now it will be fine. Okay. Huh. So it happens in the previous live session also. It got disconnected in between if it is longer than 1 hour. So please bear with me. So now the K will be omega C. Sorry, it will be omega N omega N by C, which is K0 times N. And K0 is P. Is so it is 1.5 times P. So that means the velocity is, so this is the velocity we'll get. What is that? So this is K we got. So velocity will be omega by K, that is omega by 1.5 P. And this is C by 1.5. And what is the expression for the transmitted electric field? It will be ET is JK EOT cos kx minus omega t. And kx you already calculate, it is 1.5 times p. So that means it is JK EOT cos 1.5 times px minus omega t. So you just have to find out what is the wave vector when the uh, when the plane wave enters to medium 2, then you can easily calculate what is the expression for transmitted and what is the speed inside this medium. So let us move to our next question then. So the question says, consider a X-polarized electromagnetic wave of frequency omega. It is traveling from a medium of refractive index 1.5 to a medium of refractive index 1. The wave is incident on the YZ plane at Z equal to 0 at an angle 30 degree. Then what is the expression of the transmitted electric field? Okay, so in this situation, as I said before, it's better to draw the ray diagram first. Then you can calculate what is the component of the wave vector in different direction. And according to that, you can uh, write down your expression. Okay. So the wave is traveling from refractive index. So it is traveling like this. And there is so one thing I want to emphasize is whenever you are seeing this kind of situation, so please check whether there is a total internal reflection or not. N1 is 1.5 and N2 is 1. So when the wave travels from rarer to a denser medium, it's fine. You don't have to check the, so there is no TIR, so you don't have to check whether there is a total internal reflection or not. But here, in this case, you can see the wave is traveling from a denser medium to a rarer medium. So it's better to check what is the critical angle first, so that if there is a evanescent wave, then you can easily calculate the expression for that. And if it is not, it is below the critical angle, then the wave will be sinusoidal only, right? So for this case, we have theta I, it is 30 degree, right? And this is theta r. And it is incidenting at z equal to 0. That means this point is z equal to 0. This is the y. And first find, whenever you got a situation like this, like the wave is traveling from denser to rarer medium, find theta c first. So theta c, it is nothing but the angle at which the transmitted wave becomes parallel to the plane of incidence. So n1 sine theta c will be n2. So sine theta c is n2 by n1, which is n2 is 1 and n1 is, it is given 1.5. So that means theta c, it is sine inverse 1 by 1.5, which will come around 42 degree, right? And if you see the question, theta I, that is angle of incidence, it is 30 degree, which is less than the critical angle. That means the wave will not be evanescent in the second medium. So you can follow the usual procedure. And to find out the expression, we know that EZ, it is EOZ, e to power I KZ R minus omega t. So for transmitted wave, we have ET equal to EOT, e to power I KT dot R minus omega. So your first work is to find out what is KT here. So KT, you can write it as a, from the ray diagram. So this is KT here. So KT here, you can write it as a KT is KT magnitude, cos theta r, right? Cos theta r, let me take KK. KK plus KT sin theta r JK. This is the expression for KT. So you need to find out what is the KT magnitude here and what is theta r here. Theta r and KT, you both you can find out from the Snell's law. So KT cos theta r AK plus KT sin theta r JK. And from Snell's law, you have N1 sin theta 1 equal to N2 sin theta 2. And N1, it is given, it is 1.5. And sin theta is sin, I think it is 30 degree, 30. And this one, it is sin theta 2. So that means sin theta 2 here will be 1.5 into 0.5. So this is 0.75. And cos theta 2, you can easily find out by taking root over 1 minus sin square theta 2, which will come around 0.66. Okay. So that means the KT now will be Is so second medium is say free space, right? N equal to 1. So the magnitude will be K0. Is K0 cos theta r. So cos theta r is cos theta 2 Kk plus K0 sin theta 2 Jk. And it is K0 cos theta 2 is 0.66 Kk plus is 0.75 K0 Jk. So you got the expression for the propagation vector in the transmitted medium. So now the ET, you can easily write down ET is E0t e to power I K0 is 0.75 Y plus 0.66. So there is a K0 here also. K0 is K0x minus omega t. Okay, so Y Z, right? So this is instead of X we have Z here because it is K cap. So is this question clear to you? Otherwise, we'll move to the last question.
It's clear.
Okay. So the last one is, it's similar to this for previous question, but instead of uh, angle of incidence 30°, we have angle of incidence is 45°. Okay. So here theta I, it is 45. And you can see theta C we have calculated. Theta C was around 42°. It is 42°. That means this angle of incidence, it is greater than theta C. So we'll see a total internal reflection for this case. Now if you plot the ray diagram, so the ray is incident like this. There will be total internal reflection and there will be a wave, evanescent wave in this medium. Okay. So this is angle of incidence is angle of reflection and this is theta 2. Now the transmitted wave, instead of getting a sinusoidal term, we will get a exponentially decaying term. So let us see how we can calculate it. So KT, it will be similar to the previous case. This is KT here. KT is K0 cos theta 2 K cap plus K0 sin theta 2 J cap. And cos theta 2, how we can, so sin theta 2 will be n1 by n2 from Snell's law, it is sin theta 1, right? And n1 is 1.5 and sin theta n1 sin 45. This is sin theta 2. So you already know sin theta 2 here. Now cos theta 2 will be, is nothing but root over of 1 minus sine square theta 2. So root over of 1 minus, if you plot, this is n1 by n2 square sine square theta 1. So this is root over of. So if you factor out the n1 by n2, will be n2 by n1 square minus sine square theta 1 n1 by n2, and n2 by n1 square is sine square theta c, right? And this is sine square theta 1. N1 by n2 root over of sine square theta is sine square 42 degree. So if you put n2 by n1 also, it is 1 by 1.5, right? Square minus sine square theta 1 is sine square 45, which is half. So here n1 by n2 will be 1.5 root over of 1 by 1.5 square minus 0.5. And if you calculate it, it will come around, it will come negative. So square root of minus 1, you can treat it as I. I 1.5, and the square term will come out as 0.2357. Up to 4 decimal, if you write it, it is 0.2357. So that means this is 0.53 I. So now KT will be, what will be KT? It is K0 cos theta 2 K cap K0 sin theta 2 is J cap. In cos theta 2 and sin theta 2, you already know it is K0 I 0.53 K cap plus sin theta 2, it is 1.5 by root 2, and it will come around 1.06. J. Now for the transmitted field, you just have to put this KT in the general expression, which is EOT EOT exponential I KXX, KZZ, which is I square, which is minus 1 minute. Let us write it is I K0 0.53 Z plus 1.06 K0 Y minus omega t. So there is a I here and there is also a I here. So it is minus 1. So E0t exponential minus 0.53 K0Z exponential I 1.06 K0Y minus omega t. So this is the final expression. Okay. So is this problem clear to you? It's a bit tricky one because we have to look whether there is an total internal reflection or not. In other cases, it's fine to take to just find the expression for KT and plug it in the expression, general expression. But whenever the wave travels from denser medium to rarer medium, it's better to see whether total internal reflection is happening or not. If there is a total internal reflection, then there will be evanescent wave, and if not, then there won't be any evanescent wave. Okay, so this is our last problem. I think based on this problem, I think I have solved up to 15 questions. So I think you can easily solve the problems that is given in the assignment. It's more and less, the concept is same. So if you follow the formulas and follow the concept, then you can easily solve the assignment one. Okay. And I will discuss the solution to problem assignment one in the next live session. Besides that, we'll solve some few problems that is related to with to contents. Okay. So in each Monday from 6 to 8, we'll meet and I will try to clarify your doubts, and I will solve few problems that is related to the concept that has been taught during this week. And besides that, if you have any additional problem, then uh, you can easily ask me during the live section. Okay, and if not, you can also raise your question in the group. So there is a group for this course. I think you already know. So you can easily ask your questions there regarding assignment or regarding the tutorial. If you have any doubt, then you can easily post your questions there. There are TS there who can address your question, as well as if it is related to tutorial or any conceptual, I will also try to address your concerns. Okay. So uh, before ending the live session, let me know whether you have any doubt till now. Okay. Thank you for joining the session. So I think whatever I have taught till now, I think it will be helpful for you to solve the assignment. So thank you for joining the session. We'll meet on next Monday, same time from 6 to 8. So please try to uh, attend the live session, but because it's where you can easily ask your doubts by asking me. And please if you want to ask any doubts, please feel free to ask me anytime. Please feel to disturb me anytime, okay, during the live session. So I will try to solve your doubts as well as solve some few problems also. So thank you. We'll meet on next Monday. So goodbye, everyone.